Today on Captain Kaos's laboratory, we're going to open up a calculator set for radioactivity. This is from 1978, November. It's right there on the top. It is a sealed piece of paper, or paper packaging. If you want to pause it, you'll be able to read it all and look it up. Right there. I don't know what's inside. This was in a box of stuff that came from my great-grandma. So this has probably been around, well, it's post-Vietnam, so it's been around for a while. So let's open it up and see what it is. Calculator set, Radiac and Nuclear Yield, ABC-M28A1, NSN 665-00-130-3616, which is right there. The ABC part number is not on the front. It just says A.3/79. And let's see what we got. It's like a really old unboxing or unpapering. And whatever it is stuck to the package. There we go. Make sure there's nothing else in here. Nope. We have 3 wheels riveted together. On that one. On this one, looks like there's 2. Yeah, there's an outer wheel on each side. This one says Calculator Nuclear Yield ABC-M4A1. And this one says Entry-Exit Time After Burst ABC-M1A1. Sample calculations. Calculator Nuclear Yield. That one. Says, I'll try and put it up and then I'll try and read it to you all too, without any glare. But you can pause it and read it if you want. That's side 1. And that is side 2. Wipe off the dust. Alright, sample calculations. Yield from cloud width. Align 30 seconds on flash to bang time scale within 300 mils observed cloud width scale. Read answer under pointer ANS 8+2 KT. So apparently got a lot of dust on my bench here. And it says B, align 35 kilometer on distance to ground 0 scale within 180 mils of observed cloud with scale. Read answer under pointer ANS 50+2 KT. You have to bear with me. I'm not familiar with the term, so let's just read the front of this too. The front of this is pretty much the same thing as this. Yep. Kind of interesting. Let's see how the radiant calculator works. At 1 hour after nuclear burst, the dose rate in a contaminated area is measured at 300 rads an hour. A decon team has entered the area at 40 minutes after the burst. Exit time was 10 hours. So it's telling you how to use the calculator by giving you a real-time problem to solve. Kind of like, if you're on a train heading west at 400 miles an hour and a train heading east at 340 mile an hour, old school stuff there. A, the dose rate at 40 minutes after the burst. B, the total dose received by each member of the team. Solution, align 1 hour on the intermediate disk with 30 rads. And hour. Where's the rads? There's the rads. 30. 1 hour. Right there. Hold this setting and find 40 minutes on the intermediate disk. Read the dosage rate. There. Answer is 48 plus 2 rads per hour. Huh. It's an interesting little wheel. Hour. Yeah, look at that. It says the answer would be 48, so on the opposite side, you got your rate, dose, rads, hour, right there. And the little arrow is between 45 and, 4.5 and 5. It says your answer should be 48. So that's actually pretty interesting. Here's the back of that. You can pause and read it. Try and keep the glare off of it. That way. This is the second one I want you to do is holding the same setting, align 40 minutes on the inner disk with the time of entry on the intermediate disk indicator. So take this inner wheel and we move it to there. And then it says find 10 hours on the find 10 hours on the inner disk, follow the red line guide on the intermediate disk to the outer disk, read the dosage received. It says 69. So by setting time of entry at 40, showing it would be 6 to 9. Little, hopefully not something we'll ever need. It basically gives you an idea how to calculate radiation poison. From a nuclear blast. Said, I'm sure it's not something we'd ever have to use, and I'm sure if I played with it long enough, I could figure all of it out, especially since the instructions are there, 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 and there. It's all laminated, as you can tell by the glare. So you can get it wet. It's not going to hurt anything. This feels like a paper wheel that's been laminated. That's a plastic wheel. This outer one's a plastic wheel. This is like a thick plastic. Yeah. This is plastic. Most if you got it wet, I'm sure it would just start rusting out the center rivet. So this helps you determine how much radiation you're going to get from a fallout of a nuclear device based on time of explosion to the time you go in. Probably not something we'd ever need to concern ourselves with, unless we're going to go into, you know, the Terminator type movie days. But still interesting piece of history. Sometimes these old scales are neat. I have plenty of old scales that tell you how to determine things from weather to distance just by spinning a wheel and looking at landmarks. So I'll add this to my collection of weird measuring devices. It is kind of interesting to feel this olive drab green pouch that's, well, almost as old as I am. It looks really good. Even this paper is really intact. It's not biodegraded. So it's not the most exciting video, but just something I wanted to show you that I received. That I got a sealed package and a box of random stuff from my great-grandma who died many years ago, and I found it buried in a shed. And I thought I'd be interested in having whatever this was supposed to be. So, yeah, I'll add it to my collection of weird trinkets and go from there. Stay tuned for whatever shows up the next time. Of course, we'll have more videos regarding repairs of Lemax, like most of you like to watch, fix things like this, to which I've already showed you how to fix one like that anyway, to eating some of the world's nastiest cereals. So, thanks for watching. See you on the next one.